space, that vast realm full of more mysteries than certainties, constantly taunting those researchers who peer through telescope lenses at the immeasurable emptiness that lies beyond our atmosphere. Although new discoveries are constantly being made thanks to the constantly improving technology that we have at our disposal, these discoveries do not always provide us with exact answers about space. In fact, frequently a new discovery means uncovering even more mysterious and unanswerable questions. So today, here at Unexplained Mysteries, we'll be taking a look at interesting space discoveries. The repeating radio burst. The mysterious essence of radio bursts is a spectacle that scientists have considered for ages. Radio bursts produce sprouts of fast radio waves. The duration of these powerful sprouts are milliseconds from light years away, inhabiting galaxies. Astronomers have been inept to pinpoint a consistent cycle of a radio burst until now. As of earlier in 2020, the fast radio burst 121102 was discovered to be a recurrent and distinct cycle. Fluent cycles of radio bursts are a foreign concept. The extent of the cycle consists of 157 days. The initial 67 days, the source remains mute, while the remaining 90 days, it is bestirred from its slumber. During this stage of the cycle, it gives out frequent radio sprouts before being hushed back into oblivion. Typically, traces of radio bursts that are identified only sprout once. This imposes a challenge on astronomers, as their conception is widely speculated. Subsequently, they are futile to forecast and detect. The discovery of FRB 121102, along with the assistance of other radio burst sources, has helped in growing a lead on distinguishing the mystery that are radio bursts. Before the identification of FRB 121102 cycle, it was already widely known for its activity. FRB 121102 was the most active fast radio burst discovered yet, consequently leading to the first localization of a radio burst. This research was led by astronomer Kaustubh Rajwade of the University of Manchester and his team. The justification of periodicity is becoming immense, with the benefit of multiple conclusive examinations regarding various radio bursts. The identification of its periodicity is wavering in the light of new data surfacing. A team at the Max Planck Institute for Radio Astronomy, led by Marilyn Kruse, used the Effelsberg 100-meter radio telescope to analyze FRB 121102. The team discovered 36 bursts flaring from it. With this new data, in partnership with the research conducted by Rajwade and his team, a new number of 161 days is predicted for the following cycle. However, with the use of the 500-meter aperture spherical radio telescope, Pei Wang of the National Astronomy Observatory of China and his team were able to conclude a different periodicity than the result derived from Rajwade and Cruse's teams. With the data they collected crossed over with the existing data from both teams, they believe 156.1 days is a more accurate duration. If FRB 121102 continues to show activity beyond these dates, this could suggest that either the periodicity isn't real or that it has somehow evolved. None of the data concluded is definite. The vacillating tendencies of FRB 121102 will lead most of us to have a fixation on it, leaving us only to contemplate what will happen next. Exposed bacteria can survive in space for years. Humans are curious, though egocentric creatures. For decades, centuries even, we have wondered if there is intelligent life, like us, or really any life at all out there on other planets. If there is life out there, or if any life from Earth can survive, how long can it make it in the rough conditions of outer space, and how might life move from one planet to another? Back in 2015, a robotic arm on the International Space Station managed to deposit exposed microbes onto a handrail, a staggering 250 miles above Earth. This meant there was bacteria left to be hit with the harsh conditions of space, entirely unprotected from the cosmic ultraviolet rays, gamma rays, and X-rays. The length of the experiment was just 3 years, and scientists were on the edge of their seats wondering if the bacteria would survive the duration of the experiment, and perhaps more importantly, wondering what the implications would be about the ability for life to move between planets if it did indeed manage to withstand these tribulating conditions. Looking at how organisms make it through seemingly impossible conditions is not a new concept. Microbiologists refer to these organisms as extremophiles, a term that refers to any living thing that can survive the unsurvivable. Extremophiles can be found in plenty of areas, such as deep-sea trenches, not exclusively in outer space, though understanding how these creatures can thrive in such hazardous spaces is a truly momentous task. We know in these extreme environments on Earth, some extremophiles make it through entirely unprotected for a few days, and for some they can make it years by hiding away within rocks, providing some sort of shelter. This study has revealed a little more about the extremophiles pushed into the trying climate of space. The team's findings were published in Frontiers in Microbiology in 2020, and with conclusions having been drawn from the International Space Station experiment that began in 2015, it seems as though the bacteria type Deinococcus radiodurans can survive for a minimum of 3 years in space. What makes this research even more thrilling is the suggestion made by Akihiko Yamagishi, a microbiologist at Tokyo University of Pharmacy and Life Sciences and lead author of the study, that microbial life could make it between planets when traveling, even without a rock for protection. These researchers had considered several species of bacteria, though Deinococcus radiodurans seemed particularly noteworthy following a series of trial tests. From 2010 to 2015, Yamagishi and his team took to conducting a number of small experiments on this bacteria species, recreating the conditions of the International Space Station. These simulations would allow the team to see if there was any potential for the experiment to return the results they were after before embarking on the mission itself. The team needed to prove their research held some sort of credibility before being permitted to conduct their experiment. Japan's Space Exploration Agency needed evidence of a possible success before allowing the team to try. Yamagishi commented, "We wanted to say we don't know, we just have to try it, but this isn't permitted for space experiments." Luckily, the series of simulated tests ran on the bacteria signaled they could be truly onto something. The tests included exposing the bacteria to high levels of radiation, reducing the pressures massively to create a space-like vacuum, and rapidly varying the temperatures, covering a 140 degrees Fahrenheit range in only 90 minutes. Despite all of these stresses, Deinococcus radiodurans remained strong and resistant, proving to the team they had selected a good species of bacteria from their potential candidates, and proving to JAXA that their experiment was worthwhile. This bacterium is largely impervious to the radiation, showing little signs of damage. This is understood to be due to their genetics. This, coupled with the protective outer layer that these cells have, meant the microbes survived the tough conditions of space even with radiation levels 200 times higher than those we experience on Earth. Researchers had checked the microbes annually, collecting data and conducting an analysis to check their progress and condition during each year of the experiment. When the team applied this data and these trends, they were able to predict that Deinococcus radiodurans could survive from 2 to 8 years as it travels between Earth and our neighbour, the Red Planet. This could mean that we have life not only on Earth, but also microbial life on Mars too. Yamagishi hopes that as the research continues to evolve, they will be able to conduct similar experiments even further from Earth, though only time will tell what else it is that we will be able to uncover. Monster quake on Mars is the biggest ever recorded. Since 2018, scientists have been waiting for Mars to have an earthquake. A seismometer was placed on the Red Planet and for years has recorded the wavelengths in hopes of registering a quake. Now, that has finally happened. And it's a colossal quake, at least in Martian terms. The InSight Mars lander used by NASA to detect quakes has registered a quake with a magnitude of 5 temblors at the start of May 2022. This is hardly the first quake that the InSight seismometer has detected. In the past few years, there have been over 1,300 quakes on Mars, but none as intense as this one. InSight's principal investigator, Bruce Bannett, states, "Since we set our seismometer down in December 2018, we've been waiting for the big one." Barnett is part of NASA's Jet Propulsion Laboratory in Southern California, which is the NASA jurisdiction responsible for the project. The magnitude of 5 is equal to a medium-sized earthquake felt on our planet, and Andrew Good, who also works for the Jet Propulsion Laboratory, claims that there are similarities between both quakes. According to him, the magnitude scale we use for Mars is calibrated to be as equivalent as possible to the seismic movement between Earth and Mars. Allegedly, these quakes are precisely what Andrew Good and his team hoped to see when they sent the seismometer to Mars. The seismic waves reflect material in the planet's crust, core, and mantle. With this data, scientists are able to study the depth of Mars's internal underground layers to see how they are formed and how they actually work, as well as whether the formation of Mars's core and mantle are similar, the same, or entirely different to Earth's. Bannett claims, "This quake is sure to provide a view into the planet like no other. Scientists will be analysing this data to learn new things about Mars for years to come." Although the InSight project was granted an extension until the year's end, NASA stated that it's not going to last much longer given that Mars's dust storms and winds will accumulate on its solar panels. Mars is the first non-terrestrial planet on which NASA has managed to place an active seismometer that can record its quakes. This is the biggest quake recorded on another planet, even if to us it is a medium-strength quake. The largest quake previously recorded on Mars was a magnitude of 4.2 back in 2021. Mars quakes of this magnitude are, as far as we know, very mild and uncommon to rise this high. Therefore, in terms of Mars, it's being described by scientists involved as a monster quake. This research could help scientists understand how planets like Mars and Earth formed in the first place. Even the wind on Mars can interfere with the data and corrupt it. Therefore, InSight's seismometer was made to be far more perceptive and withstanding. Volcanic activity might be a cause for some of Mars's quakes, but scientists are still unsure where or how they originate. Future data will help to further understand the way Mars as a planet works. Currently, InSight is dealing with technical difficulties. The Martian winter was cruel, and it will surely lose all power by the end of 2022 and is currently in hibernation mode. This means that it shut down all power except for its most vital functions. There is a possibility another seismometer will be sent to Mars at a later date to replace it. Scientists discover massive rotating disk in early universe. Our universe, believed to be 13.8 billion years old, has galaxies scattered across it. Most of these galaxies formed gradually, but in the past few years, the National Science Foundation have uncovered an unusual, colossal-sized galaxy the shape of a rotating disk. The galaxy, deemed DLA 0817G, but known colloquially as the Wolf Disk, after Arthur M. Wolf, is a galaxy that rotates at 272 kilometers per second, like our Milky Way. It's also the furthest disk galaxy from Earth, shrouding it in further mystery. Galaxy formation simulations showcase massive galaxies as something that formed across time via the merging of other smaller galaxies. The Wolf Disk threatens this understanding. For the most part, it is believed that this galaxies only began to form 6 billion years after the Big Bang, and yet the Wolf Disk was already formed and massive in the universe's infancy. The Very Large Array and Hubble telescopes were used by the team of researchers to analyze the Wolf Disk, but it was the ALMA radio telescope that uncovered the galaxy itself in 2017. According to Joe Pesci, a program director, this observation epitomizes how our understanding of the universe is enhanced with the advanced sensitivity that ALMA brings to radio astronomy. ALMA allows us to make new, unexpected findings with almost every observation. J. Xavier Prochaska, a professor of astronomy at the UC Santa Cruz, stated, "Its properties are astonishingly similar to our own galaxy, despite only being 1.5 billion years old." Marcel Neilman, a German professor and lead author of the study, stated, "While previous studies hinted at the existence of these early rotating gas-rich disk galaxies, thanks to ALMA we now have unambiguous evidence that they occur as early as 1.5 billion years after the Big Bang." This discovery is extraordinary due to the way it challenges our perception of reality. In Neilman's words, most galaxies that we find early in the universe look like train wrecks because they underwent consistent and often violent merging. These hot mergers make it difficult to form well-ordered, cold, rotating disks like we observe in our present universe. Neilman and his co-workers believe that the Wolf disk's immense growth happened due to a hefty amount of cold gas being involved in the galaxy's creation. And yet, this spawns more questions, such as how and where the gas came from, especially to maintain such a massive cosmic structure. The Very Large Array and Hubble telescopes were used primarily to analyze the Wolf disk's star formation. ALMA had looked at the galaxy's radio waves and its movements in terms of dust and gas. The VLA focused on its mass and fuel required to create its many stars. The Hubble telescope's job was to analyze the stars using ultraviolet light. The research proved that the Wolf disk produces stars at a velocity 10 times that of the Milky Way, if not more. As such, it must have been one of the most active galaxies in the early universe in terms of the pace of star creation. When Neilman discovered the Wolf disk with the ALMA telescope, he had been looking at a quasar near the disk. The quasar's lights was seen passing through a large amount of hydrogen gas somewhere around it, which clued the astronomers in to where the galaxy was positioned. This is a method that has helped scientists discover many rare cosmic worlds. Neilman claims the fact that we found the Wolf disk using this method tells us that it belongs to the normal population of galaxies present at early times. When our newest observations with ALMA surprisingly showed that it is rotating, we realized that early rotating disk galaxies are not as rare as we thought, and that there should be a lot more of them out there. Hubble telescope spots stunning hidden galaxy. Although scientists knew there was a galaxy past the Milky Way galaxy, they were having difficulty viewing it through debris and obstacles in the way. This is why it's called the hidden galaxy. Actually, named IC342 and also known as Caldwell 5, this newly spotted galaxy would be considered one of the brightest galaxies in the heavens if it were not for all of the cosmic clutter keeping it out of sight. Caldwell 5 appears near the center of the Milky Way's pearly disk. Viewing it is inhibited by the thick gas, dark dust, and luminous stars in the area. The Hubble telescope is able to somewhat gain vision through space pollution using infrared technology. This gives the light a better opportunity to find IC342 because it does not disperse as readily amongst the dust, giving a clearer photo of the hidden galaxy. Caldwell 5 is a spiral galaxy. Its core is classified as an H2 nucleus, a zone of ionized atomic hydrogen. These zones are active producers of new stars that form over thousands of years. As blue stars are born in the hidden galaxy, they energize their mother nucleus by giving off ultraviolet light, making Caldwell 5 a super bright galaxy hidden behind space dust. As far as neighboring galaxies go, Caldwell 5 is not too far away, a short jaunt of 11 million light-years from Earth. Even though it's about half the size of the Milky Way galaxy, IC342 is still quite large with a diameter of 50,000 light-years. The glittering direct view of the heart of the galaxy shows off twisted strands of dust, like remarkable tentacles, encircling a dazzling center of hot gas and stars. Less spectacular photos were also taken by the Hubble telescope in 2010 and 2017. As we advance in our understanding of complex theories, wrap our minds around the implications of new discoveries, and bask in the awe of ever-changing technology, we are left with a profound sense of wonder. Questions that we have pondered for centuries, such as is there life in outer space? Could another planet support the human race? Are the consequences for our actions permanent, or is there an alternate ending for our choices? All are closer to being answered than they ever have been before. This is an exciting time to witness leaps in knowledge and have information about explorations literally at our fingertips. But what do you make of these discoveries? Be sure to let us know your thoughts in the comment section below and help us by growing this community while working to solve these unexplained mysteries. Thank you for watching, and don't forget to subscribe for more videos.